All right, section 7.1, multiplication, division, of polynomials. Sorry, monomials, not polynomials. The questions that we are assigned, we started here at question number 3. It says, what multiplication statement is represented by each of the algebra tiles? So again, we're dealing with models, and we use area models to represent the multiplication of monomials. So essentially, if we think of it as a rectangle, our area is 6x squared. That's what these are right here. That's our area. Our length is these 3, which is 3x. And our width, which is these 2, is 2x. So therefore, the multiplication statement would be 3x multiplied by 2x equals the area, which is 6x squared, or the length times the width equals the area. Question B, our length and our width. Our length is 3x. Our width is negative 2x. And the area that we can clearly see inside there is negative 6x squared. Where? No, they look, no. Oh, maybe it is. I think it could be the distortion too on my computer screen. And question C, length is negative 3x, width is negative 2x. That's the world's worst 2. And we know they're negative. Why? Because they're not shaded in, or they're white, and the area inside would be a positive 6x squared. Question 5 says model and complete each of the multiplication. So here we have our area model. 2x times 4x would be 1x, 2x. Multiply by 1x, 2x, 3x, 4x. Which are solid. And the area inside, we complete the box. We simply carve out where the pieces are. We ask ourselves, are those going to be positive or negative? They are positive. So therefore, there is our solution, equals 8x squared. Our B is negative 4x times 2x. I'm going to save some time here. Well, it's probably not going to save time, but I'll take my eraser, and I'll just erase these parts right here, and I'll make them negative instead. And then because they're negative, these here will also become negative. So there's the really fast version of B. It's the exact same thing as A, except they're negative on one side and negative answer. And I guess I could have done the same thing for the next one too, because C and D are both the same. But anyway, whatever. Negative 1, negative 2, negative 3, negative 4x this way. Positive 2x this way. I always find it easier to do my shorter distances right here. It works better for me. And then those are going to be negative. Oh, those are negative and negative. Shoot. Forget that shading is there. These will all be positive because a negative times a negative is a positive. And I'm too lazy to do the last one, but you all get the idea. We're all smart enough to figure out what D is. The answer is negative 8x squared. Negative 8x squared. Question 7, find the product of each pair of monomials. This time, because we don't have to model it, what we're going to actually use here is associative property, which means the order in which we multiply does not affect the property. So if I did that, I could simplify it. This is the question. This is the answer. This is what I'm really thinking. This is the thinking to get this answer, because we can redistribute it however we want. So here, 3 times negative 6 is negative 18. A times B can't be simplified exponentially, but it can be represented by A times B as in the product of two distinct variables. Negative 1 is the coefficient times negative 9 is a positive 9. Q times Q can be simplified exponentially to be Q squared. Coefficient, fractional coefficient times whole number. People kind of get panicked about this, but it's not that hard. 2/3 multiplied by 3, which is a whole number, or 3 over 1. When you multiply that out using your fraction sense, 2/3 times 3 will be 6 over 3, which is really the number 2, right? 2/3 multiplied by 3 is 2. X times x will become x squared, so your solution is 2x squared. Negative 3 times negative 2 is positive 6. R times t is simply r times t, which is rt. RT. And finally, 1.5 times negative 3 is negative 4.5. P times P is P squared. Another way to do it, just because I like to confuse people, is if I think of this question, I'll just extend it down here for a second. It's 1.5p. 1.5p multiplied by negative 3p. If we thought of it this way, if we were using fractions, our answer would be negative 4.5 p squared, which we could actually even then say is negative 9 over 2 p squared, because I could change that mixed fraction coefficient to an improper coefficient. And then if I wanted to go even further, I could think of it as being negative 9 over 2 multiplied by p squared over 1, which would be negative 9 p squared over 2. And that, and where's my actual answer? And that are the same thing as well as this. All three of these circled parts, all four of those circled parts are the exact same answer. If you get it, great. If you don't, it's not a big deal if you don't, but it's kind of cool that you can see it that way. Question number 9 is a rectangle has a width. So as soon as I read the words a rectangle and it's a story problem, my brain automatically shifts into let's draw this sucker. A rectangle has a width of 3.9x. There we go. And a length of 5x. Ooh, I got that's a perfect rectangle drawing. What is an expression for the area of a rectangle? The expression for that will be area equals length times width. Area equals 5x multiplied by 3.9x. If you multiply those coefficients, you're going to get 15 and 4.5, 19.5 x squared. So the expression that represents the area will be 19.5 x squared. If I did my math right, is that right? Okay, good. Question 10, they took the difficult part out and they drew it for you. It says a parallelogram has a base of that. I hate when they use z's because every time I make a z, it looks like a 2. So if you make a z, make sure you put a line through it algebraically. That way it differentiates between the confusing two. So the first thing you need to know is the area of a parallelogram is just base times height. You learned that in grade 7, and then you learned that if you cut a parallelogram in half, you get a triangle, and a triangle would be therefore half of a parallelogram, and therefore would be this formula. That's where you learn how to get the formula of a triangle. But no, because that's a triangle, not a parallelogram. So when you substitute your information, your base is 8.1z multiplied by 4.2z. And when you multiply those coefficients together, oh, I can't do that in my head. 8.1 multiplied by 4.2 equals 34.02 z squared. Now notice how I hate this, because look here, that 2 and that z, they're pretty freaking close. They look a lot alike. That's why you need to have that. What's that? Well, you could do, or you can make it just like that. Yeah, I know. My handwriting is not the best, but you get the idea. Question 11, what's division statement? So again, if I thought of a simpler question that said the area is equal to, let's just make up a number of 10, and this is 5. Everybody in the room knows that this is 2, correct? You got that by taking the area and dividing it by the side you know to get the side you didn't, or area divided by side equals other side. Well, that spells a bad word, doesn't it? Hmm. What's that? So the area, which is 6x squared, divided by the side I know, which is 3x, equals the side I don't know, which if I just drew it here, are those going to be positive x's or negative x's? Positive x's. So your answer is 2x. So I have to shade these in. Question B is our first Y one. These are actually XY tiles. These are all called XY tiles. They have a Y for a length, which are these orange ones, and an X for a length. They have an X for a length. So therefore, if I was to draw these ones in here, I would have to draw X's here. And because those are positive, these would have to be positive as well. So therefore, 2y and 4x gives us gives us. So 2y multiplied by 4x equals 8xy. Notice here, if I put my y first, my x second, notice how when I made my answer, I rearranged the variables. I didn't say 8yx's. In algebra, if you have more than one variable, it's proper form to keep the variables in alphabetical order, right? It's proper form to keep. So you have to rearrange it back to xy because x comes before y. Question C, the area is negative 6x squared divided by the side I know, which is 2x, equals the side I don't know. If I just complete the actual area here by drawing it in, are those going to be positive x's or negative? They are negative because a positive times a negative gave me my negative. What number is this? I forgot to put the number in there. 12. Again, same thing. So 9x squared divided by negative 3x equals negative 3x. That's the missing side here. B, negative 6x squared, which is your area, divided by the side I know, which is negative 2x, equals, what are these going to be, positive or negative? Positive, because a positive times a negative is a negative, equals 3x. Our next question, remember these are y tiles. We'll just see if we can figure this out again. These are all xy tiles. So if I think about what are missing here, since this is positive and this is positive, these have to be positive. So my question was actually 15 xy's divided by 5y's equals 3x's. That was the solution to whatever this question is. I don't even know. I don't want to do all these. Do I have to do all of them? Let's just do A. Here's how you do it. When you solve A, I have to figure out this area. I have to figure out how to put the area in here, which is really difficult. So here's what you actually do. Don't start with the area to draw. Start with the side. So I'm going to put my side in first. And now it's a lot easier to draw in your area. So I'm going to extend this like this. You see how I did that? And now I have to figure out how to place 8x squareds in. So there's 2, there's 4, there's 6, there's 8. I'm going to shade those in positive. I now have my 8x squareds in there. And because I did that, it's now easy to figure out what is the missing sides here. Are they going to be positive or negative? They're positive. So therefore, the missing side is 4x. Okay. Do that again. I'm not going to do B because B is the xy's. Too tough. This area, this side length. So I'm going to put my thing here. I'm going to start with my side length. 1x, 2x, 3x, 4x. Shade those in because they're positive. Extend your area in. I need to figure out how to fit in negative 12x squareds. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have my areas, and I don't shade them in because they're negative. And over here, there's my missing side. Are those going to be positive x's or negative x's? Negative. So the solution is this. The missing side length is 3x. Negative 3x, thank you. And the last one, D. I'm going to start not with my area, but with my side length. I'm just going to put a negative x in there. Extend it into infinity. Try and figure out how to get 2x squareds in there. There's 1. There's 2. I can erase the rest of this because I don't need it. There it is. There's our picture. This is negative. These are positive. So now I have 2x squared divided by a negative x equals, this is going to be positive or negative? They're actually negative because a negative times a negative is the only way to get the positive. So therefore your answer is this. We good? that our last question? I'm not doing that one. Let's do this one. Oh, actually, hold on. This is find the quotient without it. Okay. So 7 divided by 1 is 7. X squared divided by x is just x. Coefficient division, 25 divided by 5 is 5. S divided by S cancel each other out. T is by itself. T remains. 125 divided by 5 is 25. T divided by nothing else below. The T remains. Negative 8 divided by negative 2 is positive 4. M divided by M cancel each other out. Your answer is just 4. 81 divided by 3 is 27. R divided by R cancels out. S divided by S cancels out. Your answer is just 27. And 4.5 divided by negative 3 is negative 1.5. P squared divided by P is a lonely old P, and you're done.